everyone. Thank you so much for welcoming me to PyCon Russia. It's such an honor to be here. I was going to make a joke about how they put vodka in the water here, but post all the bottle of vodka, so we'll just pretend. My little secret. So I'm here to talk to you today about some elegant solutions for everyday Python problems. What this is an intermediate level talk. I want to give you a whirlwind tour of some of my favorite intermediate Python features, and hopefully you old hats will learn something new too. Most of the strategies that I'm going to present today are in core Python. If not in Python 2, then in Python 3. I'm going to try to point out those differences where they're applicable. I also want to give a highlight of some relevant packages that I use and that I like very much. So if you get lost, don't worry about it. There are links to additional reading all throughout the slides. And the link to that is here, bit.ly/elegant-python if you want to follow along at home. Or here. So what is elegant code? What kind of problems are we trying to solve? I started my career as an enterprise Java developer. And I worked with some popular libraries at the time that provided features like dependency injection and ORM capabilities. But it kind of always felt bolted onto the language. I would have nightmares about things like abstract singleton proxy factory beans. Those of you who have written Java are probably familiar. I see some smirks out there. So when I discovered Python, it really felt like a breath of fresh air. Now, what is elegant code? So less is more. Elegant code can be poetic. You advanced Pythonistas might know some of these concepts. But let's be patient. I'm hoping that everyone in the room is going to learn at least one new thing today. And remember that beauty is in the eye of the beholder, so what's beautiful to me might not be beautiful to you. We've all read the Zen of Python. You know, beautiful is better than ugly, explicit is better than implicit, simple is better than complex. But how do we accomplish this? So I'm here to share some practical tips about how to make code simpler, more elegant, more explicit. The first way that we can do this is with magic methods. So we've implemented stir and repr. It lets us customize how our object is displayed. They're pretty straightforward, but we can also make our objects behave like other built-ins, things like numbers or lists or dictionaries and more. So in this code example, we have a simple currency class. It knows about the rate for a particular currency, and it knows how to represent that currency, and it knows how to convert from one currency to another. Okay, so pretty basic stuff. Here we're representing the cost of 2 meals in different currencies, soda in dollars and pizza in euros. Because we implemented that dunder repr magic method, we can see a nice printout of each of these. Now, let's implement 2 more magic methods, dunder add for addition and dunder sub for subtraction. And then let's see why this is so powerful. This allows us to use this class in a really intuitive way. It's currency, right? You expect to be able to add and subtract it, and to perform these kinds of mathematical operations on it. So these methods that we wrote, these simple, small, elegant methods are currency aware, and they do these operations in the currency of the object that we're acting on. So if the second object is in a different currency, it does the conversion under the hood. I think that's pretty cool. Some of these magic methods map to built-in functions. For example, dunder len actually maps to the built-in len function, and we'll see why that's important in a minute. So something that can make complex code pretty readable is by making your classes iterable. And in order to be iterable, a class needs to implement dunder iter. Now, what dunder iter returns must be an iterator. So sometimes these terms are a little bit confusing. Now, in order to be an iterator, the class needs to implement dunder next, which must raise the stop iteration when that iterator is exhausted. So let's say we have this sample scenario. We have a server instance, and it's running different services on different ports. Now, some of these services are active, some are inactive. When we loop over the server, we only want to loop over active services. So here we implement dunder iter. It returns self because this class implements dunder next. It's called dunder iter is called when we first start iterating. If we're looping over it in a for loop or a comprehension, that initialization process, it happens under the hood. If we need to get the iterator in a manual sort of way, we can call that the iter built-in method. So just a little example, generally we don't really want to store state in an iterator, but when you do, you can write it like this. So now we can loop over all our active services. Yeah, pretty cool, not bad. But my tip here is when you don't need to maintain a lot of state, use a generator instead of an iterator. Now, what does that look like? We have our dunder iter implemented, and instead of returning self and implementing a dunder next here, what we're doing is we're yielding a value. And in the previous example here, I had a little shim at the bottom for optional Python 2 compatibility, because this method is called dunder next in Python 3, but next in Python 2. When we use a generator, we don't need to do that. It's kind of both Python 2 and 3 compatible. The generator does some of that state maintenance for you. It doesn't really care about where it started from. It kind of only knows what the future holds. And the calculations are also lazily evaluated. So it's pretty cool. I think this is much easier to read and much simpler. So why does this work? Well, we can use these single parentheses to create a generator comprehension. And technically the term is a generator expression, but I think generator comprehension makes a lot more sense, and so does Ned Batchelder, and you can read his blog post about it here. So when I make a generator expression, it returns this generator object. Now, remember that an iterator must implement next. So here, my generator, I can call next on it. So that's pretty cool. And that works because remember how dunder len was mapped to that built-in len function? So that's kind of the same bit of functionality here. And that iterator needs to raise a stop iteration when it's exhausted. And look at that. Our generator raises stop iteration. So pretty cool. In this case, the generator is the iterator. Now, there are lots more magic methods. I highly recommend taking the time to read through them. So for example, if you want to make your object behave like a dictionary, you can implement the in keyword using contains, the get item with the brackets, set item to set items via this bracket syntax here, and delete item to be able to use the delete keyword. More reading here, emulating container types. I highly recommend it. And a really good example for advanced usages of magic methods is the headers implementation, and I always mess up the pronunciation, so let's see if I get it right, workzerg. So headers in workzerg, it's a dict-like object, and it has some special behaviors. It's ordered, so it can store the same key multiple times. It's the representation of it. It's suitable the headers are formatted for HTTP transmission. And instead of raising a key error like a dictionary does, it raises an HTTP error when a key is not present. So, pretty cool. So you learned all about magic methods. Now we're going to learn about some method magic. So method magic, a cool simple thing we can do, you saw the Python 2 to Python 3 kind of shim earlier. We can alias methods to each other. So in this example, we're aliasing a new method called concat to this dunder add method. And we can do this because methods are just objects in Python. So I can call the plus operator, because I implemented dunder add, or I can call this concat method, and when I check the identity between the two, they're the same. There's also something in Python called getAdder, and that lets us, it's a built-in, that lets us get the attribute, in this case, name from this object, and if the attribute is not found, we can provide a default. So in this case, we have class dog, and it implements this speak method. When I get adder on my dog instance with the attribute speak, it returns a bound method. And I can then call it and get this result. So here's a kind of pretty simple use case. Let's say we have a command line tool with, and we want to be able to dynamically run commands. So we have a class operations. We define two methods, say hi and say bye, and a default action. So here we have a main method, and we instantiate this class, and let's assume we have some good error handling here because, you know, given more than two parameters, this is going to barf. So now when we get adder on operations, this instance, given a command, if the command is not found, perform the default, and we take an argument. Now the output, when we run our program, if we say hi, which was the method defined here, given a parameter, it just using getAdder, we get the right method. If we try to give kind of nonsense data, it says this operation is not supported. I think that's pretty cool. Another useful tool here is partial. This lives in the functools module. It lets us kind of build a unconstructed function where we can specify defaults, and these don't take effect until that method is called. But using a partial, we can also override the arguments or the keyword arguments at a later point in time. So that works for both args and quargs. There's a library out there that I really like. It's called a GitHub. And a GitHub is a really badly named library because what it is a REST API client with transparent syntax that facilitates really rapid prototyping on any REST API at all with pretty minimal configuration. It's implemented in 400 lines of code, and you can add support for any REST API in about 30 lines of code. A GitHub itself doesn't really know anything about, knows everything about protocols like GET, REST, HTTP, but it doesn't really know anything about the upstream API. So how do we use it? We define the endpoint and our other connection properties here. We pass in a token. This is the URL for our API. And then we can just start using the API. So we instantiate GitHub here, all of the methods return the HTTP status and the data. And we could just do GH, which is the GitHub API, .user, .repos, .get, and pass in visibility public and sort created as attributes. And this automatically maps to /user/repos in the API. So black magic, right? How does that work? Well, each call on the API class ferries the call to an incomplete request. If the last call to this incomplete request is an HTTP method, then it gets the I'm sorry. If the incomplete request is a path, then it'll append that path to that URL. And here's some of that aliasing that we saw earlier. We're aliasing get item with get adder so that, well, you'll see later on, you could do a little bit of magic. If the last call is an HTTP method, what it does is it returns a partial with the method and the URL that was given. And we're getting an adder on self.client, which is defined as an instance of this client class. We define what HTTP methods we support, and then we implement the methods here. So I think this library is pretty elegantly written, and I use it all the time when prototyping. If I want to use a new API, I don't have to sit there and write a bunch of code and figure out what I do or don't want to implement. It's pretty easy. Now, what happens when we're given a non-existent path? Well, the library doesn't care. We can call, it'll just keep calling getAdder with whatever is passed into it here. In this case, this path doesn't exist. And because getItem is alias to getAdder, we can also use this bracket format here if we want to pass in values. This is useful if you have numbers, for example, if I wanted to get a particularly numbered pull request. So pretty awesome. I suggest you read the source code. It's linked in the slides, or search on GitHub for a GitHub, and this poorly named library will show up. Another tool at our disposal is Lambda. And a Lambda is small, usually a one-line function. We can use Lambda with dictionaries to make kind of a switch-like statement. So we have a default operation here. It says operation is not supported. And then we have a dictionary with some little functions defined using lambdas, for example, to double a number, return the number times 2, triple, return the number times 3. When we get an item from the dictionary, we either get this lambda or we return our default operation. And by passing num in here, we're actually going to call the function. So now we can do can use our little math function and say we want to square the number 2, and it'll return the right result. If we try to get the exponent of 5, that operation is not supported because it's not present in the dictionary. I think when used with simple statements, it's a really powerful tool that can help readability. Another popular use of Lambda is for filter, map, and reduce. But maybe I have a slightly unpopular opinion where I think these practices should be discouraged. I think that comprehensions actually make the code a lot easier to read and follow along with. If someone new to Python is looking at your code, they don't need to know anything outside of the standard library. In this example, where I'm showing you both a list and a generator comprehension. But remember that with large data sets, or if we're doing intensive computations, it's usually a good idea to use a generator instead, because then you're not filling in that list with all the data all at once. You're kind of calculating it as it's needed. Context managers are another thing that can really improve readability. So when should you use one? Well, when you need to perform an action before or after an operation. Some common scenarios are things like closing a resource after you're done with it, or network connections, or resource management. Now, let's say we have this example problem of feature flags. So what are feature flags? Sometimes they're also called a feature toggle. It's the ability to turn a feature of your application on and off easily. Maybe the value is stored in a data store, so you don't need to restart your application to, switch between features. That's pretty cool. Excuse me. So we want to only show the beta homepage to users who have opted in to be beta testers. Or we can use it to perform an A/B test. Maybe 50% of your users see version 1, 50% of your users see version 2. You track the results, and you pick the winner after running your test for a week. Alternatively, you can also use them to kind of slowly roll out features to new users. Let's say you don't know the performance impacts that a particular feature might have. So you start by rolling it out to 1% of your users, then 5%, and then you see things are stable, and you go ahead and fully release. So here's a kind of simple example of a feature flags class. We have one flag here called show beta that is set to tell us if we want to show the beta version of our homepage or not. And it has 2 methods on it. Is on, pass it in a flag name, and we'll see if it's on or off, and then a toggle feature to switch between state. So let's say we want to temporarily turn features on and off when we're testing these feature flags. So we want to be able to do something like this. We want to say, with this feature flag, assert this condition. And we want to assure that once we're out of this with statement, our flag is back to whatever state it was in originally. We can do that using the method, magic methods dunder enter and dunder exit. So we save our state when we initialize, so we know what the value of the flag was. When we start the context manager, we turn the feature on. And when we exit the context manager, we toggle it back to the old value. So that's pretty cool, but there's a better way. And that's using the context manager decorator. It lives in context lib, and it allows you to define a factory function for with statements without needing to create a separate class or implement this dunder enter and dunder exit method. And we do that using a yield statement. So here, before the yield, that was the behavior of our dunder enter, and here, after the yield, was the behavior of our dunder exit. So I think it's a lot simpler to read and lets you have some pretty powerful functionality. Now with either implementation, when we get our homepage URL, we have this method here. It returns, let's say, /beta if the flag is on, /homepage if the flag is off. And now we can use this context manager to test out all the options. We can also kind of mimic that same behavior using a decorator. So what is a decorator? It's just some syntactic sugar that allows modification of an underlying function. And I'm going to do a quick recap here in case some of you are not familiar with the concept. And even if you are familiar and regularly use them, I find that it's a topic that can be kind of hard to understand something that people are really frequently confused about. So recap, decorators, they wrap a function in another function, and they can do something before the call, after the call, with the provided arguments, or even modify the return value or the arguments to that method. So here we have a function called hello. It just says, prints out hello, given the name of the person. And then we have another function declared above it called say after. And what it does is it prints out, it was nice to meet you, after the greeting function. So without that syntactic sugar of the decorator, what's really happening is I can call say after, I can pass in the function hello, because say after takes a hello function, and then I can pass in an additional argument. Now I'm passing that argument into the hello function, and that argument is Nina. So what decorators do is they just wrap that function for you. In this case, it's doing the same thing as we saw in the previous example, except now I can just call hello Nina, and the function itself is the one that knows that it's wrapped in the say after decorator. So it's the same thing as calling that undecorated hello. Now, a quick example of closures. Let's say we have this method called multiply by, and given a number. And this method returns other methods. And we can use that to make kind of a little factory here. So let's say we want to make a method that multiplies by 5. We pass multiply by 5 into multiply by. And this returns a new method that we can now call. So if I pass in 4, I get 20. Now, decorators that take arguments kind of do the same thing as closures from that previous example. The outermost function now becomes the factory. So here we have a decorator it needs to be 3 layers deep. The first outer wrapper takes the argument that's given to the decorator. The second function takes which function it's going to act upon. And then that third inner function actually takes the parameters that we're going to pass into that greet function. So it's the same as calling this on an undecorated function. Let's say we kind of use that closure methodology. We say after bad is say this after. We pass in the argument bad, and then we pass in the argument of which function we want to use this on as hello. Now when we call say after bad Nina, we would get the same result. A problem with decorators is that you lose context with them. So in this case, the function that was wrapped has lost its dunder name property, and it also doesn't have a docstring. In order to avoid that, we want to use wraps. That's from context lib. And what we're doing is we're using this @wraps decorator, and we're going to pass in which function we want to wrap. Once we do that, we retain our dunder name and our docstring. And what I recommend is to check out the wrap library by Graham Dumpleton. It kind of does this times a million. It covers a lot of corner cases and lets you maintain a lot of introspection, whereas wraps is pretty simple. So an example use case of this, StatsD. It's an open source project by Etsy. It lets us make pretty charts and graphs. It collects statistics such as counters and timers using UDP. And then there's these pluggable backend services, Grafana, Graphite, and it lets us make graphs like this. Pretty nice. So let's say we want to increment a stats counter after making a method call. How would we implement that as a decorator? Pretty simple. We use @wraps so that the original function retains its name and docstring. And now we can use this @statsd incr decorator wherever we want to. And the key that we're using is the name of the function. And then we call statsd.increment on that and do the actual function. Pretty cool. Some other common use cases for decorators: logging, timing, validation, rate limiting is a pretty good one, mocking and patching. So a cool advanced usage of decorators is you can also modify those arguments that are passed into the underlying method and do a bit of validation. So this example comes from a code base of a startup I used to work at, and I thought it was like the coolest thing ever when I first read it. We had a lot of API methods where we had to work with a handful of common base models, and the user was one of those things that was passed around everywhere. So it was in the request if it was present. And instead of having to do this like validation everywhere, we did some magic. So here we take a flag, require user account, if it's true. So we grab the user. If the user account is required, well, if it's not there, let's just raise an authentication exception. That's going to be handled by our web server, and the request is going to die. Otherwise, we're going to take the args and we're going to change them. We're going to add user into the args, just kind of insert it into the beginning, and then return the value of the function with these new modified args. So now in our API code, we could use this decorator. It's called require auth, and we can say that require user account is true, and account will always be passed in to any function that was decorated with this, and we know that it'll always belong to an authenticated user at this point. So that's pretty cool. It's not applicable in every use case, but it's a cool, powerful tool that I really like. Something that a lot of people don't know about is a concept called context decorators. And those are context managers and decorators combined. So as of Python 3.2, they're in the standard library. Awesome. In Python 2, there's a different library that you can install via pip and use. And by using this context decorator, you're going to be able to easily write classes that can be used as both a decorator with that @ symbol, the syntactic sugar, or as a context manager with the with statement, all in one go. And it's used by, a context decorator is used by that context manager function that we saw earlier. So when you use that method, you get this ability automatically. So here's our context manager from earlier. We use the context manager decorator. This is what happens. This is what would happen in dunder enter. Then we yield a value, and then this is what would happen in dunder exit. And now we can use this feature flag decorator. We can use it as a context manager with, or we can use it as a decorator in one go. So pretty cool. A library that uses this in a really great way is called FreezeGun, and it lets you make your Python tests kind of time travel. So when you're running a test, you want to be able to pinpoint a specific moment in time. And we can use it as a context manager, so we can say, with this frozen time, make this assertion, or we can use it as a decorator on a whole method. It's pretty cool, and I have a link here. I suggest you read the source sometime. It's pretty mind-bending stuff. Another cool tool, Mixins. We can use Mixins when a class wants some new behavior, but it already inherits from a different class. So a simple example here is the timestamp mixin for SQL Alchemy models. Most of the time when we have a model, we want to know when it was created and when it was updated. And by using this mixin, we can add this to any of our models pretty simply and easily, and this kind of yucky stuff is under the hood. We don't have to look at it. An intermediate example is the user mixin that's present in Flask Security. And when you use it with your user database model, you get some really useful helper methods on model instances, such as is active, give me the auth token, does this user have a particular role? And mixins are actually not just for models, they're used in many other projects. Django uses them in views, for example. I think a particularly clever example of this is a repr mixin. It's present in SQL Alchemy. I don't think it's implemented quite in this way, but it does a little bit of introspection. So it says, give me all the columns in this name, give me the name of the, give me all the columns in this table, give me the name of the column, give me its value, and return the this representation here that kind of lists out all the column names and values. So when we use this mixin, instead of getting that yucky repr, we get a repr of this instance Nina that has the ID and the name and the state without having to implement a repr in all our models. Name tuples. This is something that a lot of you have seen. They're useful when you kind of need a lightweight representation of data. What it does is it creates a tuple subclass with some named fields. And a simple example here that you've all seen, let's say we have cache info. We call the named tuple cache info. It has a few attributes. Okay, so now we can also give our named tuples default values, and we can do that in two ways. The first with specifying dunderNew.dunderDefaults. So every time we create a new instance of this class, we'll use the default specified. Or we can use _replace to customize a prototype instance. So in this case, every new routing rule will have a default wait time of 20 if a wait time is not provided. But named tuples can also be subclassed and extended. So here we have a class person. It is inheriting from a named tuple. And it has its own implementation of stir. So when I call stir on my instance, I want this nice pretty representation instead of a representation that has the name of the class and all the different attributes. So something that's important to note here is the usage of _slots and setting that to an empty tuple. Why do we do this? So this is mentioned in the standard library documentation, but really for some reason I don't see it widely used. The special attribute _slots allows you to explicitly state which instance attributes you expect your object instances to have. And in most cases with a named tuple, we know those right off the bat. So the slide links to a really interesting case study where someone saved 9 gigabytes of RAM just by adding this empty slots to a class with 1 million instances. So when we use _slots, we prevent the creation of instance dictionaries. And because of that, it lowers memory consumption, which allows for faster access. And you can check out Pippi for other optimizations. There's 2 talks on it tomorrow. They both look really good, so I recommend you check them out. And lastly, we have signals. And what signals do is implement this pub sub model that's pretty popular in many programming languages. It allows us to decouple our applications. So we get notifications when actions occur somewhere else in the framework. Signals can let a sender notify a set of receivers that some action has taken place, Where are these especially useful? Well, when there are many unrelated pieces of code that might be interested in the same events. A library I really like is called Blinker. It provides a fast dispatching system and allows any number of interested parties to receive notifications via subscribing to signals and events. It inspires a cleaner architecture by keeping dependencies to a minimum. You don't need to deal with import hell. It can help you avoid having tightly coupled modules. Here's just kind of a simple example from the Blinker homepage. So we have a signal that a round for a game has started. We have this little method for each round. It says what the round was. We connect the started signal to this each method. And we specify another method, round 2, and we connect that, but only when the sender is 2. So now with our signal, when we go through 3 different rounds, well, each is interested in every round, so we print round 1, but there are 2 listeners for round 2, so we print round 2, and then this is round 2. And again, just round 3, because this round 2 method is no longer interested in that last signal. But Blinker does a lot more. I suggest you read the docs. You can learn about all the features. And Flask and many other extensions use Blinker under the hood. So if you have it installed, you can listen to signals from the library. Other packages have some of their own implementations of signals, such as Celery and Django. So you've learned some new things today. You have some new tools in your toolbox. You learned about magic methods and method magic, about decorators and context managers and context decorators, and also about Lambda and name tuples and signals. So Python is pretty awesome. I think it presents us with just really an incredible toolbox. It's a flexible language that has powerful features that lets us program in these fun and creative ways that I think are missing from a lot of other languages. So don't be a code monkey. It's really easy to copy and paste code from Stack Overflow or, try to stubbornly stick with paradigms of our old programming languages. And that's fine when you're working on a personal project or a script, but it's not a great idea when you're working on code that will be maintained by a team. So really resist the urge, dive into Python, open your mind to new insights and big ideas. And I will leave you with one of my favorite quotes about programming, which is, always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. And instead, you can be an elegant Pythonista and use the tools that you learned today to get started. So keep learning, because even after years of using Python, I learn something new about it every day. Thank you. By the way, if you have comments, questions, feedback, please find me on Twitter if you agree with me, but especially if you disagree with me. Send me a message, send me an email. I would love to hear from you. Thanks again.